Good day everyone, my name is Sandy Primrose and you might be wondering why you've got a male in front of you when in North America Sandy is a girl's name. Well, as you can tell from my accent, I'm Scottish, and in Scotland Sandy is a boy's name, and if you're a girl you get called Sandra. Hopefully that clarifies that little feature for you. Now, I'm a biologist with a particular interest in plants. And today I'm telling you about the language of flowers. And this lecture is in 3 parts. Each of them covers a different aspect of communication. And in the first one, I'm going to cover the reason why botanists give plants Latin names. Now, when my mother-in-law was alive, she would say to me often, "What's the name of that plant?" And I would give it its Latin name. And she'd say to me, no, what's its common name? And I tried to explain to her the problem with common names. They're very confusing, as I'll tell you in a moment. So the reason that botanists give plants Latin names is to facilitate scientific communication. Now, to give you an example of the confusion of common names, let's take a look at these 2 plants here. These are bluebells, what we in England would call bluebells. The one in the centre is the traditional English bluebell, and the one on the left is the Spanish bluebell. And quite a different flower structure, as you'll note, but the real importance for plant people is that the native English bluebell is being pushed out by the much more aggressive Spanish bluebell. So there's 2 different plants called bluebells. But if you go to my native Scotland, the plant that we call the bluebell is something totally different. It's this one called Campanula rotundifolia. And to make matters more complicated, if you go to Australia, you'll see the plant there on the left, Wallenbergia, that's the Australian bluebell. But in North America, you have the Virginian bluebell, Mertensia virginica. So if someone talks about a bluebell, we don't actually know what is the plant they are talking about. It could be any one of these. Similarly, in Britain, if you say to somebody, that's a rose of Sharon, they'll look at that yellow flower, Hypericum calcinum. But in North America, the plant that you call rose of Sharon is hibiscus, a totally unrelated plant. So the reason we give plants Latin names is to avoid confusion. Now, before the Latin system was introduced, or the Latin binomial system was introduced, sometimes plants were described by their features. And there's just one example of a plant today we call Pinus strobus. And it's much easier for me to say to you, this is Pinus strobus, than try and repeat that entire Latin description. And we also have common names which can be confusing at times. That plant there, lamb's quarters, we now know as Chenopodium album, gets its common name because it flowers around the time of the Lammas quarter in Britain, which is harvest time. But other names, we wonder where they come from. There's one, the house leek or sempervirm, welcome home husband though never so drunk. Why it gets that name, I do not know. So, the man who cleared it all up for everyone is this man, a Swedish man, Carl Linnaeus. He has various names, he goes under Carli Linnae and so on. But he introduced the system of classifying plants. And he classified them according to their mode of sexual reproduction, which means he classified them on the basis of their flower structure. And he gave the names, or the plants' names, based on a Latin binomial system. Why Latin? Well, for the simple reason, Latin is a dead language, and as such, it never changes. If you think of French, the French that they speak in France is very different from the French that they speak in Canada. Language evolves. Similarly, the English spoken in Britain is not the same as the English spoken in America. But Latin is a dead system, it doesn't evolve. Today, we use the same system that he invented over 250 years ago, but we've included DNA analysis as well. So if we look at a structure of a plant, or a flower rather, you can see it has petals, which you recognise. It has the stamens, which are the pollen-bearing structures. Any of you who have seen the inside of lilies will know them well. And then underneath you've got the sepals, all on a stalk. And Linnaeus' system is very simple. You count the number of petals, you count the number of stamens, you count the number of sepals, and these are characteristic for particular families of plants. It's actually a very simple system. So you recognise plants by the flower, not by the foliage. Now, in writing about this, Linnaeus said, "The flower's leaf serve as bridal beds that the Creator has so gloriously arranged, adorned with noble bed curtains, and perfumed with so many soft scents, that the bridegroom with his bride might there celebrate their nuptials." He could have been writing for some romantic book company, but not everyone appreciated this description. One of the other botanists in Europe at the time, Johann Siegesbeck, he called this loathsome harlotry. Now, I don't know what you would do if, after having invented something very significant, like a classification system, somebody called it loathsome harlotry. I'm sure you'd be offended. You might even go as far as to punch them in the nose. But what did Linnaeus do? Very simply, he named a very innocuous little weed after him. This is Siegsbeckia, a very innocuous little plant. That's called revenge. Now, plants have Latin names, as we've said, and these are a Latin binomial. The first part is a generic name, the second part a specific name, and they have meanings. For example, the plant on the left, Achillea millefolium. Achillea gets its name from the Greek hero Achilles, because he used this plant during the battles to stop the flow of blood in wounded soldiers. So if you take the plant and you stuff it into a wound, it contains a substance which will clot blood. Millefolium comes from the fact that the leaves are very divided, so lots of little leaves, millefolium. The plant on the right, Alchemilla mollis, mollis just means soft. The petals and the leaves are very, very soft. Now, Alchemilla, the first part, gets its name from the old-fashioned alchemists who were always trying to turn lead into gold. And they had the idea that they needed the purest water possible. And they thought that the water that collects in these leaves, which is really just dew or rainfall, is the purest water you could find, hence the name Alchemilla, after alchemy. Now, Linnaeus named many plants after his friends. This one is named after Pierre Tilland, who was a Swedish pastor. So it gets the name Tillandsia. And I don't know if Linnaeus was having a joke here, but Pierre Tilland was afraid of water. And on one occasion, he had to go to a village on the other side of a lake, which was about 10 miles across water. He was so afraid of water that he made a 250-mile journey by land just to avoid crossing water. Why do I think this might be a joke? Because this plant is known also as an air plant. It can thrive on virtually no water whatsoever. Perhaps a little joke. Now, Linnaeus is famed today for his work in classification, not just of plants, but of animals. And you might think that modern botanists would have named quite a few significant plants after him. Well, there are a few plants named after him. This is one of them, and it's actually a pretty insignificant plant, which I always find amazing. Now, the people who classify plants are known as taxonomists. Taxonomy is the science of classification. And they're not the most exciting people, taxonomists, by and large. But in naming this plant, perhaps they were having a joke. This plant was discovered as a tree, it's called sorbus, and botanists discovered that this particular specimen was a new species. So they gave it the name Sorbus admonitor. Now you might wonder, why did they choose the specific name admonitor? Admonitor is Latin, and the word today that we would associate with that is admonish. We admonish somebody, we tell them off. So why did they use admonitor when naming this plant? Well, when they found it, it had a no parking sign on it. That's what constitutes a very funny joke for taxonomists. Now, plants are arranged into families, and the families are plants which have a very similar floral structure. I'm sure all of you will be familiar with pea plants, and I've shown one there on the left. Clover belongs to the pea family. You might not think so when you first look at the flowers, but on closer inspection, you'll see they're made up of lots of little pea flowers. And another plant that'll be familiar to most of you is a lupin. That too has pea-shaped flowers. And the other characteristic they all have is they have pods. These bean pods or pea pods. That's characteristic of the pea family. Now, many people, when they come to my garden, will look at a plant and they'll say, oh, what's that plant there? Is that a such and such? And they're looking at the foliage. But if you understand what Linnaeus did, you classify plants and you name them by the flowers. These three plants all belong to the same family, the family Berberidaceae. Berberis is a shrub, a very spiny shrub. Mahonia is a smaller shrub with spiny leaves, and Epimedium is a low-growing ground plant, often herbaceous. What do they all have in common? Well, they all have in common a very similar floral structure. But you have to look at the flowers closely. So the key message, if you're identifying plants, you identify them by the flower. And today we help students do this. We have in botanic gardens what are known as Linnaean or taxonomic flower beds. This one is in Uppsala in Sweden, which was Linnaeus's hometown. And in each of the beds, you have plants that belong to the same family, and the idea is to help students identify them. It was also done in many of the ancient physic gardens so that doctors could be taught how to recognise specific medicinal plants. I now want to move on to the second topic. Why do plants have colour and scent? Well, I can tell you it's not for the benefit of us humans. It's actually a way that the plants can communicate with pollinators. And let's start with colour. There are two major plant pigments that you find. The carotenoids, which tend to be red, orange and yellow, and the anthocyanins, which are blues, purples and pinks. And it is very, very, very rare that a particular plant family will have flowers with both colours. So there's an example. These are crocosmias and they have the carotenoids, and there's geranium species and they have the anthocyanins. Now just mention here carrots. We all think of carrots as being the orange colour that you see on the right and left there, but carrots originally were black or very dark. And the orange carrots were bred by the Dutch to celebrate the House of Orange, which was the main royal family. Now, I said a moment ago, you don't see plants or a particular plant family having both red flowers and blue flowers. And yet, any of you familiar with hydrangeas will know that you can get them in red and blue. So did I tell you a lie? No, I didn't. This is a peculiar example. Those of you who can remember science at school, and you might have used litmus paper, and litmus paper goes blue in acid and red in alkali. This is what happens with hydrangeas. The pigment in the flowers acts just like litmus paper, and depending on the acidity or alkalinity of the soil, that governs the colour that you will get. Now, I'm showing there a blue rose. Have you ever seen a blue rose? I have, but it's not a natural rose. It's one that's been genetically engineered. And to me personally, it doesn't look right. There's another example. The people at Broaden show you these pictures. They look okay, but to me a rose should never be blue. But the trouble is, most of the time it appears that kind of dirty purple colour. This is not natural. This is genetically engineered. It was all the rage about 25 years ago, but now is banned in most countries. Now, many of you may be familiar with this book, The Black Tulip, written by Alexander Dumas. There was two Alexander Dumas, father and son. This one was written by the father. And although the story involves the breeding of a black tulip, there's a competition and a prize for the first person to breed one, the story is not really about plants or botany. It's really all about politics. It just happens to involve a black tulip. So the question is, can you get black flowers? And there's two examples that are quite easy to find. Many plant companies and seed companies will have catalogues that advertise black plants like these, but when you look at them, they are not truly black. They're just dark purple. There's some tulips. There's quite a few tulips are sold as black tulips. They go under names such as Queen of the Night or Black Hero or even Café Noir. That is, black coffee. But as you can see there, I'm sure they're purple. They aren't black. And the reason you don't get black flowers is that to get black colour in nature, you need melanin. Melanin is the pigment that you have in black hair when you're young, and which you lose as you get older and go grey like me. Melanin does not exist in the plant world. Now, you might say, well, I've seen it, and there's an example, tar spot of sycamore. But the real problem here is that blackness is not produced by the sycamore leaf. It's being produced by a fungal infection. So you don't get melanin in the plant world, so you won't get black flowers or black leaves. I should add, by the way, you may be interested to know, if you can remember the Chernobyl nuclear disaster that happened in 1986, well, people went back to Chernobyl after 20 years. Biologists went back to find out if there was anything living around there. And we were staggered to find that around the reactor was large numbers of black fungi, just like these ones. And the reason they're there is that melanin actually protects you from nuclear irradiation. Useful little fact to know. Now, let's talk about colour perception. The first point I want to make out is that birds and insects see colour differently from us. Now you might ask, how do we know this? Well, we know by looking at the pigments present in the eye. And if you look at the human eyes, we have in the rods and cones in the eye, we have three different pigments, a blue one, a green one, and a yellow one. And when they perceive light, that gives you the colour that we are used to seeing. Now, someone who's red-green colour-blind will be missing one of these pigments. Someone who's completely colour-blind will be missing all of them. When we go to birds and insects, we notice they have 4 pigments, not 3. And the pigment which is particularly different is the one that is shown there, pigment 370. This one allows insects and birds to perceive things in the ultraviolet range. We as humans don't see in the ultraviolet range, but they do. Now, why is this important? Well, If we look at some flowers, on the left there, that Rudbeckia, you and I will see that as very definitely yellow. What a bird or an insect will see is shown on the right. It's totally different. There again is the marsh marigold, and you can see what we see is on the left, what birds and insects see is in the centre and on the right. There's another example. Now you might ask the question, why are these markings on the plants, the ones that we can't see? And the reason is very simple. These darkly coloured parts are there to say to the insect or a bird if it's a pollinator, this is the way to find nectar. These are nectar guides. So they hone in on that and they work their way down them and they will come to nectar. And of course, in the process of collecting the nectar, they pollinate the plant. Even for plants which are pollinated by night-flying moths, they have illuminated them. These are some carnivorous plants, pitcher plants, and that what we would see is on the top, what the insects see is on the bottom. Now, when it comes to colour preferences, different insects have very different preferences. And you may have noticed in your garden or out in the wild, certain plants have certain kinds of insects associated with them, and it's all to do with colour. So bees like yellows and blues and whites, butterflies like purples and reds. So they have distinct preferences. And there's just two examples I show you on the right. Now, another thing that happens is that plants can actually be clever in other ways. The plant on the left has been infected with a mining beetle, and these silvery trails that you see are the trails of the beetle inside the leaf foliage. The plant on the right is not infected at all. It has deliberately made these white structures to pretend to insects that it has already been infected. It hasn't been, but by doing that, it's putting off the insect from attacking it, which is actually very clever when you think about it. Now, scent also plays a role in attracting pollinators, and scent works, of course, both by day and by night. You may have noticed that some plants have the flowers have a very strong smell at night time or the early evening. They're usually pollinated by moths. If they've got a pleasant smell during the day, it'll be butterflies or bees and insects like that. Now, when it comes to preferences for scent, bees and wasps are very much like humans. They have similar smell preferences. But flies can be pollinators, and flies will pollinate this plant here, the Titum arum, the largest flower in the world. If you've ever smelt it, you'll never want to smell it again. It smells absolutely putrid. It smells like rotting meat. And of course, flies are attracted to rotting animals, so they are attracted to this in great numbers and will pollinate it. This plant here, Clerodendron, which I grow in my garden, is a very interesting plant. If you go up and smell the flowers, they have a wonderful scent. They are designed to attract pollinators. However, if you take the leaves and you crush them, they have an absolutely putrid smell. You might think, well, why has the plant bothered to make something that is smelling putrid? And the answer is very simple. It doesn't want animals to eat it. So when an animal comes along and starts chewing on the leaf, it gets that putrid smell and it decides to go and eat something else instead. But the pleasant smell of the flowers will attract the pollinators. And plants can also respond to attack by insects. This is a plant familiar to all of you. It's a corn plant, and it can be attacked by the Egyptian corn borer, which will go into the cobs, the part that we eat, and cause a lot of damage, makes them inedible. Well, when that starts to happen, the corn plant puts out a signal. It's a chemical that volatilizes, it goes in the air, and that attracts parasitic wasps that come along and eat these larvae. And as Jonathan Swift, the author, said, "Little fleas have little fleas upon their backs to bite 'em, and littler fleas have littler fleas, and so ad infinitum." Here's a plant that all of you will be familiar with, lavender. Very, very strong scent. Why does the plant produce this scent? And it's a question we need to ask, because when a plant makes scent and that scent volatilizes into the air, it's expended a lot of energy in making that chemical. And plants don't do anything unless it's got a reason. The reason they make the essence that we smell, it's actually an oil that evaporates. They make it for two reasons. First of all, the vapor of the oil, which surrounds the plant, acts like an ultraviolet sunscreen. So it protects the plant, the flowers and the leaves, from the ultraviolet damage that the sun can do. The other thing it does, when the oil evaporates, it uses a large amount of energy, and that helps to cool the plant down. In the same way that we sweat when we're hot, and it's the evaporation of the sweat that cools us down. These oils are the plant equivalent of human sweat. And you may be interested to know that in Mediterranean countries, they will grow plants like this around houses, sometimes do it in Australia as well. And the reason being that when you have these plants around your house, they actually have a cooling effect on the house. So given the current worries about the price of energy, if you want to do some cooling, don't put on the air conditioning, use plants like that. Now, when we smell things, what happens is that these chemicals actually are inhaled by us, and they bind to receptors in our nose, and that sends signals to the brain. So as soon as you can smell something, there are signals going to your brain. And this is the principle of aromatherapy, and lavender is known to be a very calming substance, the lavender oil. If you're afraid of going to the dentist, smear a little lavender oil on around your face. That will calm you down. They've even found that if you put it on unruly school children, it calms them down. So aromatherapy does have a place, and it's based on the fact that these volatile scents are detected by us in receptors linked to the brain. And this leads us on very nicely to the birth of perfume. The ladies in the audience will be very familiar with the use of perfume, and even some of the men. Well, the first recorded perfume that has been written about in detail is from 1709. It was an Italian living in Germany and put together a mix of citrus oils, and because they were living in Cologne, called that eau de cologne. The exact recipe is still a secret today. The next big development came in England, what was called English fern. In actual fact, it was developed by this company called Penhaligon's, and it's based on lavender. Absolutely everything they have is lavender based. You either love it or you hate it. And then starting in the 20th century, there's some famous brands of perfume there. Number 5, still going strong today, Joy, Monsieur, Opium, Poison, and so on. And any of you who've bought perfume will know it's very expensive. Why is it expensive? Is it just the packaging, or is there a real reason? Well, if a perfume contains some rose oil, look at how you make it. You need 15 rose flowers to make just 1 drop of rose oil. 1 drop. So if we think about Chanel, what makes it so special? Well, it has some rose oil in it, but the key ingredient is jasmine oil, and that cost at the time £70,000 per kilo. So at current exchange rates, $70,000 near enough per kilo. Very, very expensive. Having said that, the bottle probably costs more than the perfume inside it. Now, let's move on to the third part, floral symbolism. And this takes many forms. This is a painting by Sir John Millais, and it's of the death of Ophelia. For those of you who know your Shakespeare, you'll remember that Ophelia was Hamlet's kind of dippy girlfriend, and she commits suicide. And this is a painting by Millais, and you might think, yes, a nice painting, but everything in that painting has a significance. So if we start, you see there's some nettles, they're representing pain. Down here there's crow flowers, they symbolise ingratitude. There's something here, a skull, which represents death. There's other things there. There's forget-me-nots. But if we look in close-up at some of these flowers there, red poppy with black seeds, that symbolises sleep and death. And we have violets. They symbolise faithfulness and death in the young. And if we go back to Hamlet, the actual text, here's one passage. There with fantastic garlands did ye come of crowflowers, nettles, daisies and long purples, that liberal shepherds give grosser names, but our cold maids do dead men's fingers call them. Well, these have significance, these flowers. Long purples is the common British orchid, and the grosser names come from the fact that the tubers look like testicles, and then the dead fence fingers, you sometimes will see the roots like that. What Hamlet is saying, this is Ophelia reaching the end of her life, and it's all about sex and death. Now, in Christian art, the violet symbolises humility. And so you often see paintings of the Virgin Mary with violets. This is one such painting by Stephen Lochner from 1430. And you might say, where are the violets? Well, look closely there, and in her hand you will see violets. There's another painting showing the Virgin Mary. And again, you might say, where are the violets? Well, they're there. Now, in the Middle Ages, violets came to symbolise faithfulness and love. And also, if you had a broken heart, you were supposed to boil violets in water and smell the scent that came off them. And so that was a way to cure your broken heart. And that's basically what this poem from Percy Bysshe Shelley is about. A broken heart. The violet is fading because love is ended. Now, if I'm giving a live presentation, I always ask the audience, who was Corporal Violet? And unfortunately, nobody ever seems to know. Well, this is who Corporal Violet was. It's, of course, Napoleon Bonaparte. When Napoleon Bonaparte was exiled to the island of Elba, his first exile, he told his supporters that he would be back in the spring when the violets were in bloom. And his supporters had a way of communicating amongst each other, and they would say to people, do you like violets? And if they said, oui, yes, or non, no, it meant you were not a supporter, you didn't know what this was about. But if you said, eh bien, then it was known that you were a supporter of Napoleon. Now, Napoleon was exiled for the second time to the island of St. Helena in the South Atlantic, never to return. And this painting was done just around the time that he was exiled. It's called Le Secret de Corporal Violet, or The Secret of Corporal Violet. And you might say, okay, it's violets, what's it all about? Well, the reason it's called The Secret is that painting actually has depictions of Napoleon, his wife, and their son. You might not see them, so I'll make it easy for you. there you see on the right is Napoleon, on the left his wife, his second wife, and down at the bottom you can see their son. This was a way of communicating when Napoleon's name was a dirty word. His second wife, who was the Duchess of Parma, she was really Marie Louise of Austria. Her father was the Emperor of Austria. He didn't want her being sent to exile in St. Helena. And at that time, Parma in Italy was under the control of Austria, so she was sent there as the governor. And at that time, she had a great passion for violets, as did Josephine, Napoleon's first wife. So she had a number of violets named after her. There's just two there, Duchess de Parme and Marie Louise. Now, if we return to love and idleness or heartsease, this is the violet. You may recall again from A Midsummer Night's Dream, Oberon describing the flight of Cupid's arrow. Yet marked I where the bolt of Cupid fell, it fell upon a little western flower. Before milk white, now purple with love's wound, and maidens call it love and idleness. Now that reference there, milk white, now purple, there is a legend that says this plant, the viola, was white until Christ was crucified on the cross, and it turned purple to represent his blood. And the last line, maidens call it love and idleness. This again is referring to the broken heart and helping ease it. And yet again, here's another one from Midsummer Night's Dream. Oberon trying to cause mischief by putting some of these in someone's eyes. Man or woman madly dote upon the next live creature that it sees. And the idea that they'll wake up, see the Queen Titania, will see the ass and fall in love with it. But you get more sophisticated symbolism in Shakespeare's works. And these are just two here from Hamlet. The first when Ophelia is talking to her brother, and the second when talking to the king and queen, Hamlet's mother and stepfather. Now, I've known quite a few Shakespearean actors, and they're very familiar with these two quotations, but they don't actually know the symbolism that's represented in them. So I'll tell you a little bit about the symbolism. Let's start with the top quotation. There's rosemary and pansies. Well, fennel stands for flattery. Columbines, male adultery and ingratitude. Rue causes abortion, symbolises female adultery, and daisy is innocence. And Ophelia, in making this quotation to the king and queen, actually is committing heresy. The other one, rosemary. Rosemary is for remembrance, and pansies, that's for thoughts. The word pansy comes from the French pense, meaning to think. Now, another family of plants, the lilies. There's many, many different lilies. I've listed a few there, and not all of them belong to the lily family. But to most people, the Easter lily is Lilium longiflorum, shown there. And to Irish Republicans, it's a different plant, Xanthodecia ethiopica. But in both cases, the lily symbolises innocence. But in Greek mythology, it has a different meaning. In the case of Greek mythology, Zeus put Heracles, his illegitimate son, to the breast of his wife. His wife had never accepted Heracles, but he put it to her breast in the hope that that would make her love their son. Heracles drank greedily from her breast, and with so much milk that some splashed across the heavens, formed the Milky Way, and where the drops fell on the earth, it became the Madonna lily. And I show there a picture of that from Tintoretto. By the way, you might not know Heracles, but you'll know him by the Roman name Hercules. But, as I said earlier, to most people, in the Greeks, it's motherhood it represents, but to most people, it's innocence. And here we have the Virgin Mary. You see her surrounded by lilies. That's innocence and purity. And you will often see lilies on gravestones. And the meaning here is the restoration of innocence upon death. So what do lilies mean today? Well, you can see in the top right there, the white lily, purity, chastity, innocence. That's what, of course, we think of with the Virgin Mary. On the top left, you see stargazer lilies, as they're known, and that means I see heaven in your eyes. The bottom one, romance and talent, and the yellow ones, falsehood, living for the moment. And I have to say, many years ago, I had a PA, and I would from time to time give her flowers for her birthday or on special occasions. And I very often gave her stargazer lilies. And given that she was 15 years older than me, to say, I see heaven in your eyes, I realise now it was the wrong thing to give her. But fortunately, she didn't know the meaning either. Now, the concept of floriography had roots in the Turkish harems in the 1600s. And later on, it appeared in Europe. Lady Mary Wortley Montagu introduced the concept. And this concept came about around the time when we were becoming much more tight-lipped, a lot more conservative. It was the Victorian prudence and so on. So if you wanted to convey a message, it would be the wrong thing to speak it, but you could communicate in flowers. And flowers had different messages, and the flower, you'd give a gift of somebody some flowers if you wanted to convey a message, and these flowers or gifts were known as tussie-mussies. So, how good would you be with these? So a single red rose, what does it mean? Love at first sight, or I still love you. A bunch of red roses, be mine. White roses, will you love me? And yellow roses, you might have guessed from the lilies, dying love, infidelity, jealousy. How about these? Bamboo, longevity, strength, ability to cope with adversity, because a bamboo shoot can bend with the wind, doesn't break. A three-leafed clover, the Holy Trinity, God the Father, Christ the Son, and the Holy Ghost. Orange ones, pure and simple hatred. Then the last ones, lack of success with the opposite sex. Now, you may recall from my introduction, my surname is Primrose. So if I gave my wife some of these, what would it mean? It would mean, I can't live without you, woman. So to finish, a little cartoon from Snoopy, Peanuts rather. Do you know what you'd be saying if you gave me an Austrian rose? You'd be saying, thou art all that is lovely. And if you gave me a La France rose, you'd be saying, meet me by moonlight. And the fetus rose would express your infatuation. What about no rose at all? That's not in the book. Thank you, everyone. That's the end. Thank you.